Hello everyone! Today's joke of the day is, why do birds fly south in the fall? Stay tuned to find out. Our learning target for today is I can order numbers from least to greatest in varying forms. Okay, so now that we've kind of learned about some different types of real numbers, we are going to try and order them from least to greatest. Okay, so some of them are in different forms. So let's look at this first example. We have the square root of 64, the square root of 40, 6, the square root of 50, and 7. Okay, well, 3 of these are already in square root form. Okay, so what we're going to do is try and help ourselves out by putting 6 and 7 in the square root form. Okay, well, 6 is the square root of its square. Okay, so let's think about 6 squared gives us 36. So 6 is going to be equal to the square root of 36. Okay? And 7 will be the square root of its square. So 7 is equal to the square root of 49. Okay? It's perfect square. Okay? So now these are all in the order of, or are all in the form of square roots. So it'll be a lot easier to order them. Okay? So let's look at this. Let's just look at the numbers inside the square root. 36 is the smallest of those numbers. So the square root of 36 is going to be the smallest number. Okay? And then after that comes the square root of 40. Then the square root of 49, then the square root of 50, and finally the square root of 64. Now I just want to change these numbers back into their original form that they were in. Okay, so if I look back up at these numbers in the black here, this square root of 36 was actually just written as 6. So I'll keep that as 6. And then square root of 40 was square root of 40. Square root of 49 was written as 7. Square root of 50 was square root of 50, and square root of 64 was square root of 64. Okay? Now we can always double check our answer to make sure that we got it in the right order by using our calculator. Okay? So if I look at my calculator and I type in square root of 40, that gives me something close to 6.32. Okay, good. So that's more than 6, but less than 7. Great. The square root of 50, if I put that in my calculator, that gives me 7.07. Okay, so that's slightly more than 7. And the square root of 64 we know is a perfect square, so it would be 8. Okay, so we got those in the right order. So that's how we can check it. Okay, let's look at this next example. Here we have the square root of 16, 3.9, 41 divided by 10, for 41 tenths, and 4.01. Okay, this one's going to be a lot harder to write into square roots, so let's write them all as decimals so that we can compare them. Okay, so the square root of 16 we know is equal to 4. That's a perfect square. Okay, 3.9 is already in a decimal form. 41 divided by 10. Okay, well, 41 over 10, when you're dividing something by 10, you're just moving the decimal place one place to the left. Okay, so that would really be 4.1. Okay, and then we have 4.01. So now we want to order these from least to greatest. Well, the smallest one is definitely going to be 3.9. Okay, we know that that is the least. Okay, and then let's look at these other ones. Then would we have 4, 4.01, or 4.1? Well, 4.01 is slightly more than 4 because it's got that extra 0.01. So 4 would come next. And then 4.1 is definitely greater than 4.01. So that 4.0 would come next, and then 4.1. Okay? And then finally, let's rewrite these back into the forms that we were given. Okay, so 3.9 is still 3.9. 4 would be the square root of 16. 4.01 is the same. And 4.1 was written as 41 over 10. Okay, so you see how we can kind of manipulate the form that our numbers are in so that we can figure out which order they go in. Okay, let's look at this next example. Here we have 6, the square root of 32, 8 over 2, 5, and the square root of 20. Okay, well, these ones might be a little bit more easier to write as square roots. Okay, so the square root of 6, we know that that is equal to the square root, or 6 we know is equal to the square root of 36. And 5 we know is equal to the square root of 25. Okay, but I don't know what 8 over 2 is equal to. Well, 8 over 2, 8 divided by 2, that gives us 4. Okay, so this is equal to 4. And then we can square that, and 4 is equal to the square root of 16. Okay, so now that they're all in square root form, it'll be a lot easier to order them. So here the smallest one would be the square root of 16. And then we have the square root of 20, the square root of 25, square root of 32, and the square root of 36. Okay, so now let's just rewrite them back into the forms that we were given. So square root of 16 was originally written as 8 over 2. So we'll start with that one. Then square root of 20 stays the same. Square root of 25 would be 5. Square root of 32 stays the same. And the square root of 36 is equal to 6. Okay, so we know that we ordered them. And I can always check that in my calculator by finding the square root of 20 and the square root of 32. But I'll leave that for you to do on your own. Okay, let's look at this next one. All right, this one has some negatives in it. Okay, but we can still rewrite these all as square roots. So 4 we know is equal to the square root of 16. Negative square root of 2 is already in a square root. Now this one's a little tricky. Negative 2, well, we know 2 squared is going to be 4. So it'll be the square root of 4. But we want to make sure that we keep it negative. So we're going to add that negative outside of the square root. Okay, here we have negative 6 over 2. That gives us negative 3. And then we want to write that as a square root. Well, 3 squared is 9. So this will be the negative square root of 9. 0 we can write as the square root of 0 because 0 times 0 is 0. And then square root of 15 is already in that form. Okay, so now this one we have some negatives, and so we want to think about our number line. Okay, so we want to think about like if this is 0 on our number line. Okay, and we have 1, 2, etc. And then we have negative 1, negative 2. Okay, the numbers that appear bigger are more negative, so they're actually smaller. Okay, so out of all of these, we want to just look at our negatives right now to figure out which one is the least. Okay, well, we would have the negative square root of 9, negative square root of 4, and negative square root of 2. Well, negative square root of 9 would be the least because it would be the farthest away from 0. So we have negative square root of 9, and then it'd be negative square root of 4, then negative square root of 2. So that's all of our negatives. Then we would have 0 or square root of 0. And then we want square root of 15 and square root of 16. Okay, so our final step, just rewrite these back into the original form that they were given to us. So we would have negative 6 over 2, negative 2, negative square root of 2, 0, square root of 15, and 4. And that would be our final ordering. Okay, let's look at this next one. If we have the negative or the absolute value of negative 5, 3 squared, negative 5.1, positive 5.1, and the square root of 10. So this one looks like it'd be easiest to just kind of think of them in their decimal forms. So I'm going to simplify the absolute value of negative 5. Well, that's 5 because you take the absolute value, distance away from 0, that gives us 5. Then negative 5, 3 squared would be 9. 3 times 3 is 9. Negative 5.1, 5.1. And then let's think about the square root of 10. Well, that's really close to the square root of 9, which is equal to 3. Okay, so this one's going to be just slightly bigger than 3. Okay, so then if we're going to order them, we would start with the smallest one. Well, which one would be the most negative? We have 2 negative answers here. We have negative 5.1 and negative 5. Negative 5.1 is less than negative 5 because it's further away from 0. So we'd have negative 5.1 and then negative 5. Okay, then what's our next smallest number? Well, it would probably be the square root of 10 because that's just slightly more than 3. Square root of 10. And then we still have 5, 5.1, and 9. So it would be 5, and then 5.1, and then 9. Oh, I wrote 5.1 instead of, or 5.9 instead of 5.1. Okay, 5.1. All right, and then final step is just to rewrite these in the form that they were given to us. So we have negative 5.1 and negative 5 were written the same. Square root of 10 was good. this 5 was written as the absolute value of negative 5. We had 5.1, and that 9 was written as 3 squared. Okay, and that would be our final ordering for these ones. All right, one last example. Okay, these ones, again, it'll probably be the easiest to write these just as decimals. So let's think about negative 18 divided by 9. Well, that is equal to negative 2. Okay, so then let's order these. And we know that the negative square root of 2, well, that's going to be between negative square root of 2 is going to be less than the negative square root of 1 and greater than the negative square root of 4, because the negative square root of 4 is 2 and the negative square root of 1 is 1. So it's going to be between negative 2 and negative 1. Okay, so it'll be somewhere in there. That will be helpful in ordering. Okay, so here, then our smallest number is going to be this negative 3, and then negative 2.5, negative 2. Then this one's going to be a little bit bigger. It's going to be right in between negative 2 and negative 1. So we'd have the negative square root of 2, and then negative 1 would be our final one here. So final step here, just rewrite them back in the forms that they were given to us. So we have negative 3, negative 2.5, negative 18 over 9, negative square root of 2, and negative 1. Okay, and that's our final ordering. So in summary, if we are trying to order real numbers that are in varying forms, we want to put them all in a form that we can work with, okay, so that we can figure out the order and then rewrite them back into their original form, okay? So for the joke of the day, why do birds fly south in the winter? Well, because it's too far to walk. Thanks for watching and have a great day.